Alrighty, welcome to the next video. This one is going to be about point-slope form of a line. So again, we're dealing with linear equations and linear graphs, but this is just an alternate way to write the equation of the line. Instead of using slope-intercept form, you can use point-slope form. This one actually is a little bit more generic in that it's not quite so specific because you can use any point on the graph instead of only using the y-intercept. So both of them use slope. The y-intercept is required for slope-intercept form. And for point-slope form, instead of having a restricted point that you have to use, you're allowed to use any point on the entire line. You could use the y-intercept if you wanted to, but you could also use some other point besides the y-intercept. So this is how the equation looks. It starts off y minus y1 equals m times parentheses x minus x1. So just like before, x and y are your two variables, and they will stay as x and y. So when you write this equation specifically for a given line, the x and the y will stay x and y, but the m will be swapped out for an actual numerical value. So whatever you found your slope to be, you're going to plug that in for m just like before. And then, we said one point on the line. It doesn't matter which point it is, but you have to know one point on the line. So x1 and y1 will be the actual coordinates of that point. So, it could be like 3, 4 or something like that. But you're actually going to plug in a number for y1 here and a number for x1 here. So you'll have numbers here, here, and here, and x and y will still be variables. And I know at first glance it does look a little funny. This format may not be as intuitive as slope-intercept form, but in a slide or two I'm going to show why the formula is what it is, and hopefully that helps you remember what it is. Okay, so first just the concept. A line can be defined if you know any point plus the direction. So the direction tells you rise over run, which is slope. So if you think about if I say start here at this point and go up 1 over 2, up 1 over 2, up 1 over 2, up 1 over 2, there's only one line you can draw that has that property of starting at this point or going through this point here and having this certain slope. So I'm just trying to motivate the idea that if you know a point and you know a slope, that guarantees a specific unique line. There's not more than one possible answer you could have if you know a point on the line plus the slope. So, start here, go up 3 over 1. 1, 2, 3 over 1. Once you've nailed down where you're starting and where you're going, there's only one possible line that you can draw that goes through those points. So it's unique. If your graph and your equation are unique if you know those two things, any point plus a slope. Okay. So how do you get this equation? It looked a little nasty. I want to show you how to get it. So normally if you want to find the slope, you have m equals rise over run, and you find the difference in your y values and the difference in your x values for any 2 points. So suppose you've got a graph and here's your line. Okay, we can label this point right here x1, y1. And now this point, normally we would have labeled it x2, y2, but instead we can just label it xy. Because x2, y2 is a specific point on the graph, and x comma y, this is not x1, this is x comma y. This point could be anywhere. It could be here, it could be here, it could be here, it could be here. So in general, it could just be anywhere along this line. So we just don't have to give it subscripts. We can just call it the point x comma y. It represents any point on this line, whereas x1, y1 is a specific point on the line with known values, with known numerical values. Okay, the slope of this line is going to be rise over run, and the slope, whatever it comes out to be, we're going to call m because that's the variable we use for slope. So if we use this point and the slope m, we can write the formula m equals let me finish this here. It's y2 minus y1 over x2 minus x1. But this secondary point is just xy. So let's go like this. We can do y minus y1 over x minus x1. So instead of y2 and x2, I just have y and x, no subscript. And now, this formula technically is true, and there's nothing else we have to do to it, but it's kind of nice to not have a fraction, right? So to get rid of this fraction, I have to multiply by the entire denominator, which is x minus x1, and whatever I do to cancel out this on the left-hand side, or sorry, on the right-hand side, I also have to do on the right-hand side, left-hand side, God, I can't talk, sorry. So I multiply by x minus x1 on the right to cancel these out, so I also multiply by x minus x1 on the left, and now I've got this x minus x1 multiplied by m, and of course when you multiply two things, the order doesn't matter, so we can switch the order of those two, and we can also switch the left-hand side of the equation and the right-hand side of the equation. Again, this is just the way you're writing things, like if you write x equals 7 or 7 equals x, it's the same thing, you can change the order. So we write this y minus y1 on the left, and then we put this stuff on the right, putting the m first, and the x minus x1 second. And there you have it. So really, point-slope form of a line is just a rearrangement of the equation to find slope between 2 points. So it's nothing like completely brand new, it's just a different way of expressing it, okay? So if you plug in numbers for both coordinate points, you can find out a numerical value for the slope. If you plug in a number for one of the points, x1 and y1, but you leave the other point as a variable y and a variable x, then you'll end up with an equation of a line representing all of the points that are contained within that starting point and that slope. Okay, let's use point-slope form to draw some graphs and write some equations. So suppose we're given a point, negative 2, 3, and a slope of negative 2. Let's write the equation and then draw the graph. So we start with the formula, y minus y1 equals m times x minus x1. We fill in what we know. The y1 is the y value, which is 3, so I can write y minus 3 equals m is negative 2, that was my slope, and x minus a negative 2 becomes x plus 2. So writing the equation in point-slope form, if you're given a point and a slope, is really easy. I mean, that's why it's called point-slope form. Now to graph it, we can plot the point that we know, negative 2, 3 is back 2, up 3. That's the point that we know. Okay, so we plot the point that we know, negative 2, 3, and then the slope tells us which direction to go and how far. So slope of negative 2 means from this point we need to go down 2 over 1, plot this one, down 2 over 1, down 2 over 1, down 2 over 1, etc. And I can, again, remember to go backwards, you do the opposite. So instead of going down 2 and forward 1, I can go up 2, back 1, up 2, back 1. And of course, these all line up. So if when you go backwards you do something wrong, it should be obvious because the points won't line up very well. If you do it right, they should all line up in a nice straight line. And again, you should use a ruler or an edge of a piece of paper or something like that if you have one. So here's the graph of this equation. Y minus 3 equals negative 2 times parentheses x plus 2. That means it has the point negative 2, 3 and has a slope of negative 2. Let's try another one. Point slope. I can write my equation, y minus y1 equals m times x minus x1. And again, I want to emphasize that you're writing the equation before you plug in the numbers. So y minus y1, but y1 is a negative 4, so minus a negative 4 becomes positive 4. The slope is a 1, and in parentheses here it's x minus 0. Okay, so typically you don't need to simplify point-slope form. You can leave it kind of in this stretched out, expanded version. But if you have something with a minus 0, you really shouldn't write it. It's an eyesore, so to speak. And 1 times x is really just x. So you can write it like that. I mean, this one is not wrong. It makes it very explicit that this is the value of the point and this is the slope. But this is kind of nice and beautiful, so we kind of like that a little bit better. Now let's draw the graphs. So we start at the point 0, negative 4. That's going to be down here at negative 4. In fact, that's a y-intercept. So remember before I said, with point-slope form, you can use any point. So in this case, it's actually the y-intercept that we're starting at. And the slope is 1, so that just means up 1 over 1, make a dot, up 1 over 1, make a dot, up 1 over 1, make a dot, up 1 over 1, etc. And then we draw a nice straight line through all of these points. And make sure you put arrows on the end of your line to show that it keeps going, it doesn't stop. Otherwise it'd be a segment rather than an actual line. Okay, so there was our y-intercept at negative 4, which is nice to label. So here's our equation, and here's our line. Okay, let's see, finding the y-intercepts from point-slope form. So suppose you're given this equation in point-slope form, how do you find the y-intercept? So there's two different ways you can do it, and we're gonna use the two examples we just did to find the y-intercept. So let me go back one slide. Here's the two examples we just did. This one was really easy to find the y-intercept, obviously, because the point was 0, -4. And this one might be a little more tricky. So the intercept is, you can look at the graph right there and see that it's at, it should be at -1, but we want to do some calculations to confirm that. Okay, so we've got this equation, y minus 3 equals -2 x plus 2. So one thing we could do, that's the same equation we had before, I just am rewriting it. One thing we could do is we can solve this equation for y. That's option 2. I'll get to option 1 in a second. We can solve this equation for y and get y equals mx plus b format. So to do that, we should distribute this -2 in and get -2x minus 4, y minus 3 equals. Then we can add 3 to both sides, and then we get y equals -2x, -4 plus 3 is -1. Okay, so we get y equals -2x minus 1. You can look at it and tell that that's the y-intercept, because the equation is now converted from point-slope form into slope-intercept form. Then you can just look at the equation and get the y-intercept. Okay. Alternatively, option 1 would have been plug in the given info to the slope-intercept equation. So we could say, ignore this one for now. We could say y equals mx plus b. I know my x and y values, -2 and 3, so I can plug in a 3 here, a -2 right there. I know my m value is -2 plus b, and now I can solve. So -2 times -2 is 4, so 3 equals 4 plus b, and now minus 4 from both sides. Cancel, -1 equals b. So in both cases, you can see that you get the same value as you must for the intercept, and you can do whichever one you prefer. This one, I'm just going to say this is the y-intercept. So if it's given to you, try to be clever and observe or realize that. So b equals -4 because they gave us the point 0, -4. So we don't have to do any work to find that one. Okay, that's it for finding the equations in point-slope form. Remember that the point and the slope are the only two things you need. You can plug them right into the equation, and then when you're trying to draw the graph, start at wherever the point that they give you is, and then follow the slope to get the next point and the next point and the next point as you go up. All right, let me know in class if you have any questions.